this lesson, we're going to find the domain and range of rational functions. In this example, we're asked to find the domain and range of the given function. This is the parent function, the reciprocal function, which is one of the basics of all rational functions. So in terms of finding the domain algebraically, you want to know what are all the values of x that I'm allowed to plug into this function. And you can plug in any number. The one number you can't plug in, though, is a 0, because if we put a 0 in the bottom, it's going to become undefined. But any other number is fine. It could be a negative number, positive number, you name it. You just can't plug a 0 into this function. And so what you're going to see is for the domain, x equals 0, you're going to have an asymptote there because 0 is not part of the domain of this function. It is all real numbers except 0. So to write that in interval notation is going to be like so. Now, you can look at the graph itself. Remember, for the domain, you basically want to know how far that graph extends both to the left and to the right. And because it has arrows there, it's going to go forever and ever to positive infinity to the right, and it's going to go to negative infinity there to the left. The only value that is not covered is 0. And again, our graph will never touch or intersect that vertical line because x is not part of the domain of this function. What about range? Range is your set of y values. If you look at your graph for the range is how far this graph extends up and down, and because we have arrows there, it's going to go forever up to positive infinity and forever down to negative infinity. And again, there's an area that is not covered on our graph, and that would be at y equals 0. So we will have a horizontal line there at y equals 0, that asymptote there, which means the same thing for the range is going to include all real numbers except 0. In this example, we're asked to find the domain and range for the function f of x equals 1 over x squared. So notice this function is a little different from the other. Let's start out by finding the domain. What are all the allowable values we can plug into this function in place of x? Well, regardless of whether that number is negative or positive, we can plug in any real number there, because when you square a negative number, it becomes a positive. Square a positive number, it becomes a positive. So it doesn't matter what number you plug in here, but the one number that does matter again is 0. Because if you square 0, it's 0, and you can't have a 0 in the bottom of any rational expression. So therefore, 0 again is not part of the domain of the function. We can also see from our graph, looking at it visually, that our graph hugs and gets really close to 0, but it does not touch the x equals 0 line there, the asymptote. So we have a vertical asymptote at x equals 0, and our domain includes all real numbers except 0. And now for our range, our asymptote, yes, it is y equals 0, but our range is not going to be the same as the domain here. So for our range, we want to know how far does this graph extend both up and down? Well, the graph never goes below the x-axis there. The graph gets close, but not even touches it. But it starts there at 0 does not include 0, and it's going to go and continue on and on because you have these arrows on the end. It's going to go forever to positive infinity. So our range is from 0 to positive infinity. In this example, we're asked to identify the domain and range of the graph, any vertical or horizontal asymptotes. So let's start out with the vertical asymptotes. Where do you see the vertical asymptotes here? If you said -2, +2, that is correct. How about horizontal asymptote, where the graph gets really close to but does not cross? Yes, it at y equals 1 is where your horizontal asymptote. What is, because notice here is where the horizontal asymptote will be, okay? So it wouldn't be down here like you may think it would be there at 0, but no, it's right there at 1. Now let's find the domain. So the domain, how far this graph extends to the left and to the right, or over the entire domain here. Well, there's only two values here that where we have these asymptotes where it would not reach on that domain. So we would have to exclude -2 and +2, and our domain will be all real numbers except those two values. So written in set builder notation, that's how you would write it. And then our range. How far does this graph extends both up and down? So it looks like the graph would be at every point, but the points that are excluded from the domain would be there where our asymptote is, and that is at 1. So it's going to include all real numbers except 1. Okay, your turn. I want you to find the domain and range of the given rational function. If you look at the answer choices, it's written in a way to where the domain and range includes all real numbers except certain values. So pause the video for a moment, take a look at the graph, and see if you can identify those values that are excluded from both the domain and range. Okay, so let's see how you did. So in terms of the domain, I'm looking for the vertical asymptote to where the line gets close to but never touches, and that would be at, yes, x equals 2. For the range, I'm looking at the y values. In other words, I'm looking at a horizontal asymptote to where the line approaches but never touches. So therefore, it's not part of the range. And what would that be? Yes, that would be a 3. You got it. And so that is answer choice B. Identifying the domain of a rational function algebraically. So if you're given a rational function and asked to find the domain, recall the domain of a rational function will contain all real numbers except those values that would make the denominator 0. In other words, that would make it undefined. So all you need to do is simply take the denominator, set it equal to 0, and solve for x. Whatever the value of x is, that is the value that is excluded from the domain of a rational function. So let's go ahead and take the bottom and set it equal to 0. To solve for x, we would have to add 5 to each side, and x equals 5. So to write that in set builder notation form, that the domain includes all real numbers except 5 will look like so. So that's set builder notation form, interval notation form, all real numbers except 5 will look like so. And there you have it, the domain of a rational function. Here we're asked to find the domain of this function. Recall that the domain of a rational function will contain all real numbers except those values that would make the denominator 0 or undefined. So in this function that we're given, the only number that would make the bottom undefined is the number 0. So that means that for our domain, we can plug in any number we want into this function, but the one number we can't plug in is 0 because 0 would make it undefined. So to write that in set builder notation form is going to look like so, and interval notation form will be following. And there you have it, the domain of a rational expression or rational function. In this example, we're asked to find the domain of the rational function and write our answer in interval notation form and in set builder notation form. So recall that to find the domain, all we have to do is simply take the denominator and set it equal to 0 and solve for x. And whatever values of x is, those are the numbers that are excluded from the domain. Because remember, with rational functions, the denominator cannot be 0, so that is why you must set the denominator equal to 0 so that you can find out which values are excluded from the domain. So to do that, we're going to add 2 to each side, then divide by 3, and x equals 2/3. So I can plug any number into this function, but the one number I'm not allowed to plug in is 2/3 because 2/3 would make the bottom undefined. So to write that in interval notation form to mean that the domain will include all real numbers except 2/3 is going to look like so. Interval notation following. And now it's your turn to find the domain of a rational function. So pause the video, give yourself some time to work the problem, and when you're ready to reveal the answer, go ahead and restart the video. Okay, so how did you do? All right, let's see. So recall that all we have to do is take the bottom and set it equal to 0 and solve for x. So the fact that the back end is a positive, the signs are going to be the same. What kind of signs? The middle term tells us they're going to be 2 negatives. So let's go ahead and put that in. All right, so I need to know a pair of numbers that when I multiply them, that gives me 48. And at the same time, if I add those two numbers, they're going to equal 14. And yes, those numbers are the 6 and the 8. So now to set these two parentheses equal to 0 and solve for x, for the first one, x is going to equal 6, and the other x is going to equal 8. So that means that these are the two numbers that must be excluded from the domain because these values would make the bottom undefined. So as we can see, what choice is that? Yes, you got it, choice C. And there you have it, finding the domain of rational functions. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.